Hey everyone, and welcome to the second lecture in the series of lectures on probability. In the first lecture we talked about the introduction of probability, the basic concepts related to probability, some of the terms related to probability, and how we see probability all around us. In fact, how we use probability in our daily lives without even knowing that we are using the concepts of probability. Now we go to the second and third concepts of probability, which are permutation and combinations. We'll start with permutations, and before we start with permutations, I would like to talk about another concept that is called the factorial. Now, the concept of factorial is such that if you see any number like 3 over here and you see an exclamation point right besides it, it basically means that this is a factorial. So this exclamation point over here means that this is a 3 factorial. This is a factorial of 3. How do we solve factorials is that we multiply the number that we are taking the factorial of with the number that is 1 less the previous number. For example, over here 3 factorial is going to be 3 multiplied by 2 multiplied by 1. Just like that, 5 factorial is going to be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Now if you want to go beyond that, if you have a 7 factorial, if you want to take the factorial of 7, you're going to have 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. We keep multiplying the number till the point that we reach 1. That is what factorial means. Now keep this in mind, because this is the concept that's really central to the understanding of permutation and combinations, and it can also help you in a lot in counting the number of combinations that you can make of particular subjects or particular objects. Now let's start with the permutation is. Now if you have an arrangement of something, or if you have an index, if you have a list of something, and in that list an order is really important, then that would be called a permutation. That arrangement will be called a permutation. Now we see a very simple example of this dial lock over here in front of you. Now if you have the password or the way to unlock is 17-31 and 5, like the 3 combinations to opening this lock is 17, 31 and 5. Of course, this is not the same as 31, 5 and 17. So we'll say that 17, 31 and 5 is actually a permutation, because if you enter 5, 17, 31, 31, 5, 17, no matter how you enter this, you're never going to open the lock. So in this particular scenario, the arrangement and the order is important. That's why this is known as a permutation. If it were not important, that would be a combination, but we'll talk about that later. Forget that for now. So this is a permutation. This is a definition of a permutation, that if you have an arrangement in which an order is important, then that is called a permutation. Even in your life, if you want to arrange something, like let's just say you want the sitting arrangement in a particular company, in a particular place, to be like you have 3 boys first and 3 girls after that. Now if you want to seat these 6 people, you need to keep in mind this permutation. That is the only way you'll be able to follow this thing of keeping 3 boys and 3 girls sitting in the way that was required. The order may seem very simple for now, because you might think that what's the difference between the different orders. In different scenarios, order does not matter, or it does not matter that much. But in this particular case, the thing is, the only way the lock is going to open if you follow a particular order. If you don't, then it's not going to open. So you see that the permutation is really important in this case, and you need to keep in mind the permutation. So moving on, now let's try an example. So this example will be really helpful for you to understanding the concept of permutation. So the question is that the manager of a coffee shop needs to hire 2 employees, one to work at the counter and one to work at the drive-thru. Sarah, Megan, Trisha and Jeff are all have applied for this job. How many possible ways are there for the manager to place the applicants? So we have altogether 4 applicants. So what do we do? Rather than just thinking of what we do, we make basically a chart. We make a chart so that we try to understand which employee we can fit where, and which can be used at the counter and the drive-thru. So we need 2 employees over here. So we write down these 3 columns: counter, drive-thru and outcomes. At counter we have Sarah, Megan, Trisha and Jeff, and then we add the different combinations, the different ways in which we can arrange the different employees. Like for example, over here if we have Sarah at the counter, then on the drive-thru we can have Megan, Trisha and Jeff. On the other hand, if we have Megan at the counter, we can have Trisha, Jeff and Sarah on the drive-thru. If we have Trisha, we have the 3 that are not on the counter, that is Sarah, Megan and Jeff, and so on and so forth. So we make different outcomes. We see what the outcomes would be. So S and M would mean Sarah and Megan. So that means we choose Sarah for the counter and Megan for the drive-through. So we have SM over here. Then we choose Sarah for the, then what if we choose Sarah for the counter and Trisha for the drive-through? We have ST. So just like that over here at Jeff, if we have Jeff at the counter and Megan at the drive-through, we have JM. On the other hand, if we reverse this and we have Megan at the counter and Jeff at the drive-through, we're gonna have MJ. So these are the particular outcomes. We're just using this so that we could understand the different outcomes that we might get by using these two ways. Now moving on. So you see there are 12 different ways for the 4 applicants to hold the 2 positions. So we know there are 4 applicants and we have 2 basically ways in which we can fit them: counter and drive-through, drive-through and counter. So after doing this, what we do is we try to find out the permutations of this. But how do we do that? First of all, we recognize this that we have 4 applicants. Now with the help of this chart, we found out that there are 12 different ways in these 4 applicants could be arranged, and we know that there are 2 positions. So this is the data. 4 applicants, 2 positions. When we fit them, we get 12 different ways. Now let's go back to the definition of permutations. We know this, that the definition of permutations tells us that the arrangement is very, very important. Now over here we see that the arrangement was important. Why? Because we had 2 unique positions. So if the 4 applicants were to be arranged in those particular positions, we would know that the arrangement is important and the arrangement was necessary. So we know that this question will be solved by the help of permutations. How do we do that? We use the symbol P to denote a permutation. 4P2, as you can see on your screen right now, basically says for the number of applicants to be filled, in fact to be arranged in 2 different positions. Remember that this is how you translate. You have 4 objects, in this case 4 employees, that need to fit in 2 different positions, and they have an order. So if they have an order, so we will call that a permutation, and this is how we're going to solve it: 4, P and 2. Now the way to solve this is you can also use the fundamental counting principle to determine the number of permutations. Ways to choose the first employee are 4, ways to choose the second employee are 3, because that we saw with the chart that we made. But of course this is going to be really complex when you get to the higher combinations. For example, what if you would have a question that would involve 7P4 and another second event that would have 11P8? So how would you go on solving that? That would be really difficult for you, right? So another way to do that is by the help of the formula of permutations, which of course is, as you can see, we will drive over here, 4 into 3 into 2 into 1 over 2 into 1. How did we get this? Now let me explain to you. 4P2 can be translated into this: 4 factorial over 2 factorial. How did we get this? We got this by the help of a simple equation, simple way, that is first of all, let's talk about the journal one. The journal way to denote a permutation is NPR. N over here is 4, R is over here is 2. N is the number of objects taken R at a time, basically arrangements. Taken R is the number of arrangements, that how many ways can you fit in different objects. So you have NPR over here, so you're going to have 4P2, that's going to be basically 4 factorial over 2 factorial. How did we get this? It's not as simple as that you just write 4 over here and 2 over here. No, the real formula is this, that once you have an NPR, then you have n factorial on the top. That is the simple one, that the case that we got over here, that is 4, we had the n over here, and it's going to be n factorial of the top, that we got 4 factorial, and the denominator is going to be 4 minus r. That is, in this case, is going to be n minus r is going to be 4 minus 2, and then we're going to get a factorial of that. Just because it turns out 4 factorial over 2 factorial, don't be confused by it. So the way to do was n over here is 4, r over here is 2. We get n factorial over here, that is 4 factorial, and we get n minus r, that is going to be 2, 4 minus 2 factorial, and then we have the answer to that one. Now moving on, let's see how we solve this one. 10p6, what do you have over here? 10p6, 10p6. So 10 over here is basically the n over here and 6 is the r. So what are you going to get? How about you write it down? The best way to solve this is that you write it down. If you write it down, you're going to see that it is 10 factorial over 10 minus 6 whole factorial. So you're going to get 10 factorial. Of course, what do we know about the factorials? 10 factorial is going to be 10 into 9 into 8 and all the way up to 1, and 10 minus 6 is going to be 4 factorial, which is going to be 4 into 3 into 2 all the way up to 1. So this is what you get. So the answer to this question is going to be very large answer. That is going to be, of course, before you solve this, you need to simplify it, because that's the best way to do it. Of course, you can do it with the help of a calculator. All you need to do is plug in the values. You already have a factorial function in your calculator. So instead of doing that, why don't you cancel out all these terms with these terms in the end? 4 into 3 into 2 into 1. The denominator is going to cancel out the terms in the numerator, and this is what you're going to get. Moving on, you'll see that the answer is 151,200. Different permutations of 10 objects arranged in 6 different ways, that is taken 6 at a time. Now let's look at another example for this to help you further understand permutation. So this example basically says a computer program requires a user to enter a 7-digit registration code made up of digits 1, 2, 4, 5, 6, 7 and 9. Each number has to be used, that is you cannot skip a number, and no number can be used more than once. That basically means that you cannot have 1, 2, 4. That means basically that you need to have all 7 of these, because if you repeat any number, you're going to have 2 of those and then you're going to leave out 1. But the one of the arrangements is that each number has to be used, and the secondly is that no number can be used more than once. So one follows the other. If you use each number, you cannot have more than once, more than the one number more than once, and if you use that, then of course you cannot have the first one. So now let's try to understand how do we solve this. Question is, how many different registration codes are possible? Question number 2. So let's solve this one first. Since the order of the number in the code is important, the situation is permutation of 7 digits taken 7 at a time. So we know that 7p7 is going to be like we're going to solve it, n factorial over n minus r factorial. N factorial is going to be 7. That is going to be 7 factorial. This much we know. What about n minus r whole factorial? That is going to be 7 minus 7 whole factorial. Now one thing that you need to memorize, well, it's really pretty simple. That is 0 factorial is equals to 1. So we have 7 factorial over 1. So we have the answer to this is 5040. So how many different registration codes are possible? The number of different registration codes are possible is 5040. Try to understand the question. The question says you have 7 digits that you need to enter, taken 7 at a time. How many different permutations can you make? Because all 7 are taken. This is a part of the question. So there are 5040 possible codes with the digits 1, 2, 4, 5, 6, 7 and 9. Let's look at question number 2. What is the probability that the first digits of the code are even numbers? Now we already talked about probability. Now this one is from the previous lecture. So the total number of outcomes are 1, 2, 3, 4, 5, 6, 7. As we see 1, 2, 4, 5, 6, 7, 9. So the total number of outcomes is going to be 7, of course. And over here we have the total number of outcomes. So you see, you might be wondering that we can just put in 7 in the denominator and we have 2, 4 and 6 as even numbers. So the answer is going to be straightforward as 3 by 7. But no, look at the question. The question is the number of total outcomes. Of course, use the fundamental counting method to determine the number of ways for the first 3 digits to be even. This is one of the ways to do it. Of course, this is going to be really complex and really long. If you start putting it, then you do it again and again. So the thing with that is that over here we'll have to use the fundamental counting principle to find out the number of even positions, to find out the number of even combinations. Basically find out that the first 3 digits of the code are going to be even number. Of course, if the first is there are 3 numbers that can fit in the first spot. After that is done, then there are 2 in the second, then there's 1 in the third one. After this is done, of course, now we come to the 4th digit and there are 4 odd numbers to choose from. So there are 4 ways that the 4 digit could be odd. And of course then there's 3, 2, 1. So we have this, these are not the numbers, these are the number of numbers that can fit in this particular situation. The number of even numbers that can fit in the first one is 3. Once 3 are done, then the next one is going to be 2, and the next one after that is going to be 1, because you only have 3 even digits. So moving on, we already know the answer to this. That is going to be 144. 3 multiplied by 2 multiplied by 1 into 4 into 3 to 1. This is the way. This is the way we find the combinations of the number of even digits in the first 3 places of this number. After we are done with that, we already had the number of possible outcomes. That is all the outcomes that we saw, and we saw that over here. That was 5040. So we have the numerator, we have the denominator, and so the probability of the first 3 digits of being even is actually 144 by 5040. What I want you to do is go over this example once again, because this is a really good example in order for you to understand how different scenarios can be can look really complex, but they're really simple in the end. So of course the probability, you need to simplify it, that you're going to get 1 by 35, that is going to be 35%. So this is pretty much it for permutations. We'll be starting with combinations after that, and that will be all for today's lecture. Hopefully I'll see you again in the next lecture on combinations, but please do look at these examples once again. Thank you very much.